So the product rule says suppose f and g are both differentiable at x equals a. Okay? We have to assume that the underlying functions are differentiable. That is, we're saying suppose f prime and g prime exist. Okay? That's what does it mean to be differentiable? Why don't you as a student go all the way through till the final exam and say, I don't know what differentiable means. It's easy. It means the derivative exists there. Okay? Sounds like a large, complicated word, but remember that not all functions are differentiable everywhere. You can't always compute the derivatives. Specifically, we've seen at cusps and at corners and at vertical tangent lines, you can't compute derivatives. Okay? So assuming that we can take the derivative of the underlying functions at these locations, what is the derivative of the product of these two functions? How do we compute the derivative of the product of these two functions? Okay? Folks, your initial gut is not going to work here. You cannot distribute the derivative over the product. Everyone, let's say that together. You cannot distribute the derivative over the product. You might, anyway, even though you just said it. You can't. Okay? So how do we take the derivative of a product? Well, the product rule, which we'll prove in a different video, says you take the first times the derivative of the second plus the second function times the derivative of the first. Folks, if you've had some calculus before, you might have memorized this in a different order. That's okay. You might memorize it by a different little string of expressions. That's okay. For those of you that are new, though, I ask you to learn it this way. We say that you take the first, this is the first here, times the derivative of the second. We got the operation plus, watch that. And then what do? We take the second, and then we multiply that to the derivative of the first. So you'll want to memorize that. Okay? There's an easier way to remember that. You say you multiply each with the other's derivative. I've just linked the 3 blue, 1 brown video where he goes through a nice visual interpretation of the product rule. Highly recommend you take a look at that. Okay? But as far as what do you need to memorize? Some variation of this expression here. Okay? So we summarize this by saying the first times the derivative of the second plus the second times the derivative of the first. Okay? So let's do number 6 together. So we need to identify two separate functions here. Let's identify the first function. What's the left product, the left factor in this product?
E to the power of x.
E to the x. What's the right factor in this product? Okay. Folks, if you make mistakes, go back to what I'm doing in this video right here. To be honest, come class tomorrow, I will just start doing the product rule. I'll just start writing it out. Okay? But for right now, let's practice actually following this formula. We would say that h prime of x is equal to, we said the first function, which I'll write as f of x, times the derivative of the second function. Oof, I don't know if I can do all this switching. G prime of x plus the second function times the derivative of the first function. Okay? I've given myself a nice little roadmap. You do not have to actually write this part out like this, but I think it's helpful as you first learn the rules. Okay? So let's see here. We've got the first function, which was e to the x, times, and I'm gonna be a little bit pedantic here, folks, just to practice using this notation. Okay? If you don't like what I'm writing on the board right now, ask yourself, is it because you're worried about running out of pencil lead, or because you're still not completely comfortable with this notation? If it's because you're not completely comfortable with this notation, well, let's keep writing it out. Okay? Plus, so let's see here, we've got g of x, which is x to the fourth, times, by Leibniz's notation, we're going to take times the derivative of e to the x. Does everyone see what I just wrote there? Okay. I oftentimes, when these problems get large, use Leibniz's notation to sort of take a breath. Okay? I might be in the middle of computing a very large derivative, and I just get to a particular component that I'm not ready to take the derivative yet. So I just pause and I say, in a moment, we'll take the derivative of e to the x. Okay? If you feel comfortable doing it right away, go ahead and do so. But this is just sort of a nice bookkeeping procedure. All right, here we go. We get e to the x times 4x cubed plus x to the fourth times e to the x. We'll just park our answer there. All right, folks. Warning. I don't use exclamation marks lightly. All right? So there's one of them. So take heed, because I see this all the time. The derivative of the product is not the product of the derivatives. Okay? So here you get to see Thorsten's error. Okay? And then I'll have you explain the mistake and fill it out. I'd like you to go ahead and do that on your own time. We're going to move on to the quotient rule next. So I'm going to get through the quotient rule and then turn you guys loose on the in-class work. So I'll let you guys work through 8 and 9 after class. All right.